I started doing freelance work up here. I was commuting once a month from Washington, which is 500 miles each way. I helped put MANTA together originally. And then through that contact with Dave Greene, I got hooked up with Jack at Nimbus, and I built that place for him.
Jack Richardson?
Yeah. Well, that was 72 when I first came up from MATA, and that got me introduced to the scene up here pretty well, and did a lot of work. Got stiffed a couple of times, but that's life in the big city. There weren't too many people that could do what I could do, to be quite honest with you. At the risk of tooting my own horn, but I have an approach that is radically different from a lot of other people, and it's based on physics rather than, oh gee whiz, let's try this. And most people don't work that way. We took the hum and buzzes out of a whole bunch of places. I remember I got a call from Cy down at MANTA. This must have been about 83, because that's when we bought the first house anyway. He says, we got this hum and we can't find it in the control room. And he describes the situation, and I drove down there and had a listen, and I said, okay, we're going to have to find a day like Saturday or Sunday when you're dark, and we're going to have to be able to turn off all the power to the building until we find out where the hell this thing's coming from. Oh, no problem. Well, prior to when I got there, what happened is they had a 24-track Studer, and it was a 45-degree angle in the corner in this little soffit kind of thing, the way they used to do control rooms. And they would have to take the machine out and rotate it around to get the hum out of the record head so that they could overdub. And a couple of inches made it or break it. So somehow they got it into their heads it must be a magnetic field. So where's the field coming from? Well, they went out on the sidewalk and they look up, and here's this utility pole with the pole transformer that's feeding the building. Oh, well, that has to be it. So they got hydro in. They cut down the pole. They put another pole on the other side of the street. They trenched the street. They got everything back together for God knows how many thousands of dollars, and it didn't make the slightest bit of difference. Not 1/2 a dB. So that's when Cy called me, and I went down, and he showed me how you rotate the machine and whatnot. And they had several problems, but the one problem that nobody knew about, including me at the time, was that where this machine was stuck into this soffit in the wall, on the other side was a storage closet. There was a single light bulb on a pull chain on the ceiling of this closet. And there was a piece of BX that went through the wall, a surface mount, over which they put the fuzz, the acoustic panels, with fiberglass, whatever the hell they were. And they were using 3-inch drywall screws. And where the cable penetrated the wall, they ran a drywall screw, and this is BX, right, which is aluminum jacket up here. They ran a drywall screw through the jacket and hit the neutral. Okay, so now we have neutral current flowing back down the spiral shield. Well, I went over to the panel and we popped it off, and we had, 3 or 4 volts of neutral to ground voltage. Now that I knew what I was looking for, we found it with an induction loop and a speaker, as it turned out. And I remember we found out what it was, and Cy says, hold on. He comes back about a minute later with a pair of bolt cutters, like you cut the chain off a fence with. And he goes whomp, and he cuts this BX. It was hot. Sparks flying all over the place. No more hum. That was it. It was the H field around the wire due to the neutral current. And what that introduced me to was the concept of neutral bonds, which is definitely the biggest deal there is when you're tracking down interference in a building. It takes one bonded neutral anywhere in the building. If it's a steel frame, which most of them are, you got H field everywhere. That's the magnetic field. E field is electric. And if you ever go into a place with a single coil and you got to do one of these things, you got a neutral bond somewhere in the building that's responsible for that. And it takes one neutral bond in a building, whether it has anything to do with the technical power or the equipment or anything, and you're screwed. So you got to go through the whole bloody building and track down all the H fields, which are usually, there's more than one, and get rid of them all. And all of a sudden, everything will shut up, and you can use your single coils without any problem. The field strength has got to be no more than 2 milligauss maximum, and 2 milligauss is one hell of a small field. And I have a Gauss meter that'll measure it, but it's all the way down at the lowest, most sensitive range. Anyway, I've spent a lot of time in the last 20 years tracking down noise in big installations of all kinds. And older buildings, you just go in with the understanding that you're going to have neutral bonds coming out of your ears. It turns out when you're wiring a building and you have a breaker panel at the service entrance, there is a screw in the neutral bar which bonds the neutral bar to the box, and then that's what you send to your ground rod. That's the building ground, that's what it's called. Now that is a lightning prevention. That's your last line of defense against lightning. Because prior to that, theoretically, there's going to be a transformer that'll block most of it, but that's your last line of defense. You can't build a building without a neutral bonded at the service entrance, and that's in the code, both here in the States. But anywhere else in the building, you're going to use the same panel, which they do all the time. You have to take that bonding screw out. When I go to New York next week, this is the Juilliard School of Music we're talking about. Building was built in '67, and I'll be willing to bet you a great steak dinner that we're going to find neutral bonds all over the place. Because the electricians back then didn't have a clue. The EEs, for the most part, didn't have a clue. And until you get all that out of the way, anything else you do, I mean, the next thing you do is you go around and start looking for pin 1 problems. And that's a whole new ball game, but there are some techniques and some hardware that I've developed that makes it pretty easy to do that. And after doing about a dozen facilities, including 2 others that were designed by the same EE outfit that designed this place. There's a company called Ove Arab. They're a big international contractor. They do all kinds of stuff. Anyway, the building was built in '67. They have never been able to get the equipment quiet, in spite of spending a boatload of bucks about 10 years ago and not making any difference. And I had already done another project for them in a different part of the building with the same problem when we were about 2/3 of the way through, and they ran out of time and money because the room was almost constantly in use. And they happened to have a black week, and we got in there, or a dark week, I should say. But we had to basically scuttle the project. This is the same building, different floor probably. I don't know the details yet. But this time I know what I'm looking for, from having done a couple of other major similar projects where the EEs, they put in 3-phase, damn the torpedoes, they're putting in 3-phase whether you like it or not. Screw the audio, they could care less. And this will be my 3rd project designed by the same company, different EE every time. They just don't give a shit. Anyway, so it's going to be a fun week. And my colleague and boss, Tom Young, is flying up Friday night, and we're going to drive down Saturday. Anyway, he worked for Phil for a while, and now he's in Connecticut someplace, I forget where. But anyway, he got me the first big gig, which is the New Jersey Performing Arts Center, and that was a friggin' nightmare. We finally tamed it down, but it wasn't easy. And the EE, one of the fundamental problems with both New Jersey and Philadelphia, it was an RTEC project to start with. And they had this spec, an electrical spec, that was about that thick, and it was an absolute guaranteed formula for doing it wrong the first time. And I beat up on them to the point where I think somebody was about ready to punch me out. And it finally became evident that they weren't going to do anything about it. And as far as I know, they're still issuing that spec, and they're still having problems in the jobs that they've done. But in any event, one of the things that this spec says is, well, we're going to have a 200 amp panel over here, we're going to have one there, we're going to have one on the loading dock, we're going to have one on FOH, and you get this list of 200 amp panels, three-phase, right? And the EE adds up all the 200 amps and throws in a fudge factor, and that is the size of the isolation transformer they put in downstairs in the hydro room. Well, in both Newark and Philadelphia, we cranked up every single sound system in the building to about 100 and something close to 110 in C-weighted pink noise. And we went down and we measured the current that the sound system was pulling. The whole goddamn sound system in both of these things was about 120 amps. Not very much. They had, in the New Jersey one, they had a 750 kVA isolation transformer, which was the size of my van standing up on end. It made so much noise that you couldn't hold a conversation in the room, and there was enough juice in that thing to run all the sound systems in northern New Jersey without any trouble. And these idiots had no idea that when you say 200 amps, they're not going to all be used at the same time. They're not all going to be loaded anywhere close. But that's what touring companies want, and I mean, that's just sort of what this spec said you had to do. There's something called diversity, which is a term that they don't understand, obviously. So anyway, that transformer pulled more current magnetizing itself than it delivered under full load to the sound system, which is where all the hum, noise, and heat came from. That room must have been 100 degrees, middle of the winter. And Philadelphia, same contractor, same spec. This time the transformer was only 500 kVA, which is enough to run all the sound systems in Philadelphia 2 or 3 times over. And they spent, I know in Philadelphia, they told me they had $1.5 million worth of conduit for the technical power before they started pulling the copper. And they pulled a couple $1 million more copper. And what was so stupid about this design, both of these big rooms were N1, which is the threshold of hearing. And in Philadelphia, the FOH panel was on stage right. On the back wall of the stage was the company switch for the touring sound company. They were about 50 feet apart physically. Between the front of house panel and the hydro distribution, which is on the floor below, and back around to the rear wall, there was 1,400 feet of green wire. You know, I mean, and this is like number 4, size of your thumb. You figure out what that copper was worth. 1,400 feet. So now you take an XL from one panel to the other, and you got hum coming out of your ears. And that was one of the problems at Philadelphia. It was an IA house, and the stagehands were never getting any kind of a decent sound check because it took them all the time to try and get the sound system quiet because of all these visiting, road rigs that would come in. So after a year, the head IA guy booked an appointment with the managing director of Philadelphia, and he went in and he pounded the table and he says, either you fix this goddamn thing or we're walking. Now, if the IA walks, they got a dark house. You're screwed. You can't bring in scabs or there will be hell to pay. So that's when I got a call from Phil Giddings, who had just visited there just to see the place. And so I went down, and it took us 5 or 6 trips to get to the bottom of it, and we basically abandoned the technical power and grounding system altogether because it was impossible. The amount of money it would have cost to straighten it out was probably another $500,000, and they didn't have $500,000 to spend on anything at that point. New Jersey wasn't quite as bad. New Jersey had a different problem, though. Another N1 room, 3-phase power, and they had a whole flock of elevators, both serving the performance area, 3 or 4, and then they had another half dozen or so in the building. And all these elevators are running on electronic motor drives called VFDs, of variable frequency drives, which means the frequency determines the speed of the motor. Well, and zero frequency being the motor is stopped, basically. Well, what was happening is that, first of all, they had wired this thing three-phase delta with no ground in the pipe, which I don't know how the hell that ever got past the inspector. But the ground current coupled through the elevator motor into the steel frame of the building was going everywhere, the H field. And it was all this high-frequency crap that went way up above 20 kilohertz. And we used a spectrum analyzer to look at it. And in the performance space, when two or three of these elevators are doing the same, going up and down, you got all these little tinkly noises out of the sound system. And it turned out it was the harmonics of these VFDs beating with each other. So their solution, up until I got there, was during a performance, they turned off the elevators. Now, can you imagine being the fire marshal and walking in on that scene? I mean, they would have had the padlocks on the doors before the, unbelievable. So we methodically went through the whole place. I brought a friend of mine from up here who eats that stuff for breakfast. I wasn't all that into motor drives back then. And we've discovered what the problem was, and we figured out what they were going to have to do to permanently fix it, which was to put drive isolation transformers in front of all these VFDs, which they had edited out of the budget for lack of money. We were 50 mil over budget when this thing came in. If they had done the drive isolation transformers to start with, there wouldn't have been a problem, but they didn't. And so that was one thing. The next thing we found is that every piece of equipment in that whole place, except for this big, nice Yamaha console, I forget what it was, but something really nice, which was bulletproof, everything had a pin 1 problem that would just stop a battleship. And one of the things that were the worst of all is they had these 8-channel BSS active mic splits with input and output on the back, XL times 8. And up on the front, they had 2 XL outs, but the pin 1s were lifted. And I remember doing a Juno down at the O'Keefe, back when it was the O'Keefe. And they were having problems. And Bill Coons got in there and said, well, here, this is going to fix your problem. So he rented them a whole rack full of these things. And as long as you used the front panel outputs, it was clean. Now, these things are $3,500 a pop for 8 channels, and all it was 8 pin 1 lifters. So in a situation like that, they couldn't afford to replace them. And BSS didn't want to know about it. I mean, they were being harmonized at that point, so forget them. What we did was we pulled the shield out of all of the mic lines and tied it right straight to the chassis on the outside of the box, and that got around the pin 1 problem for that box. And then we had to go through everything else in the room and effectively do the same thing. And we finally got the room mostly quiet, so that it was a lot better than when we started, one of those things. And we also had to abandon the tech power in that room and the tech ground and just go back to the regular building ground. And between all of those various moves, that got them quiet. But they ended up with $500,000 worth of tech power that didn't do them any good, aside from that stupid transformer, which I just about croaked when I saw that thing. And Philadelphia was similar, except they didn't have any pin 1 problems. That was remarkable. That was the first place I'd been in where nothing had a pin 1 problem, and it was all common mode voltage because of the big long green wires running around the place. So that was mind-boggling, I want to tell you. But we managed to quiet them down, and the stagehands were happy, and I got paid, and all that kind of good stuff.